Hi, let's wait for 1 or 2 minutes, then we can start the session. Okay, I think we can start the session, and as people will be joining, they will continue from that point. And at the end, anyways, I'm going to summarize it how we are solving the problem. So, hello, my name is Arpit, and I'm a PhD scholar from Department of Electrical Engineering, IIT Bombay. And as I request everyone to please mute themselves. Yeah. Yeah. So I'm a TA for this course, digital circuits. In our previous sessions, what we covered is basics of number system, floating point arithmetic, and combinational circuits, logic gates, and introductory sequential circuits, right? So in today's session, what we are going to do is we are going to solve a few problems related to uh, some circuits which contain both combinational as well as sequential logic, and how to figure out how to solve what will be the output for a given set of input. Then so timing diagram, as I mentioned it in last class, that it is going to be very helpful for us. We will see how, and we will do some problems on counters and one or two variety of counters in this particular lecture. So if anyone has any doubt at any point, please feel free to unmute yourself and ask the doubt. Okay, so without further ado, let's start our today's live session. This is live session 7. Okay, so the first question is the initial state A, B, C, E of this particular circuit. It is 1001. So we have to figure out how many clock cycles are needed to reach the state 0110, right? To solve this type of problem, let's first mention what is the present state and what is the next state. Okay, so I'm going to use a few notations. Like if I use x plus, so it means this is the next state logic, right? Sorry, the next state. So it is given to us that the initial state is 1001. So I will start my present state with that. Okay, 1001. And it is given that A, B, C, E is in this order, right? So the next state we can mention that A plus, B plus, C plus and E plus, okay, which refers to our next state. So if A, B, C, E is 1, 0, 0, 1, okay, so what is going to be the next state? As we can see that the D input is being driven by E bar, okay, so it means whatever E was present, we have to take the complement of that in the next state, okay. So let's start from E plus, right? So sorry, let's start from A plus, okay. So A plus will be nothing but E bar. E is 1, so A plus will be 0, okay. Then similarly in the next state, the previous value of A, that is going to be, right? So the value of A is 1, so B plus will be 1, okay. Similarly the value of B will go to C, right? Whatever was the previous state or the present state, that will move as it is to the next state in this fashion. B will go to C, C will go to E and A will go to B, right? So this is what happens in the first clock. Let me call it 1, okay. In the next clock, our present state will be 0, 1, 0, 0. So can anyone tell me what is going to be the next state?
1, 0, 1, 0?
Yeah, 1, 0, 1, 0. So now my next present state is 1, 0, 1, 0. Okay. So now what should be my next state?
1, 1, 0, 1.
1, 1, 0, 1. Okay. So next is 1, 1, 0, 1. What should be my
next state is 0, 1, 1, 0.
Okay, 0, 1, 1, 0.
That is the desired output.
Yeah, correct. So
A is the answer.
Correct. A is the answer. Because after 4 clock cycles, we arrive at our desired output, that is 0, 1, 1, 0. Right? So does anyone have any queries in this particular question? So this was just as a warm-up exercise, and but still these the methods that we are going to use, it will be helpful in the further questions that we are going to solve. So does anyone have any query in this question? Okay, so let's move to the next question. Okay, so in this question what we are given is, we are given 2 D flip-flops, okay, and we have to figure out the frequency of the signal at Q1, okay. So we have to figure out what is this particular frequency. So before we attempt to solve questions like this, the first step should be, we need to figure out what is the equation for D1 and D2, okay. So for D1 my equation is going to be, so I can see there's an AND gate, okay, let me put a dot. Then I observe that Q2 bar is one of the inputs for AND gate, so I'll write Q2 bar, and another input is Q1 bar, okay. So that is my D1. Next, what is my D2? So D2 is nothing but it's a wire that is connected between Q1 and D. So D2 is Q1, okay. Now we will take the help of timing diagram to solve this question, okay. So the first thing that I'm going to do is, I'm going to draw the clock, okay. So let me mark clock like this. Is my screen updating?
Yes.
Okay. Okay. So after clock, let me put D1. Yeah, and here I want you to pay attention closely to this case. So the D1 is getting updated, okay, in a combinational fashion. So it means the moment these two inputs change, let me call it x and y, so the d1 will change accordingly immediately without waiting for the clock pulse, right? Similarly d2, okay, because d2 is just a wire between q1, so the moment q1 changes, d1 also changes, d2 also changes, sorry. Okay, so let me assume that d1 is starting from a state 0. Okay, let me draw the clock lines like this. Okay, and this is a positive edge triggered clock. So okay, so in the initial state when d1 is already 0, so what is going to be q1 bar and q2 bar? Because q1 and q2 will also be 0, right? So I am assuming everything is at a reset. So q1 bar and q2 bar is 1 1, right? So d1 will also be 1 at the arrival of the first clock edge, right? So let me mark d1 like this. Okay, then after d1 let me put q1, d2, q2. Okay, and as I mentioned that all the outputs are initially reset, so q1 is 0 and this 0 continues. Okay, similarly even q2 is 0, and yeah, q1 and d2 are connected, so whatever is the value of q1, d2 will be same. Okay, and q2 is initially 0, so we will mark it like this. Okay, so now let us figure out what happens at the second clock edge. Okay, so at the second clock edge, so the value of q2 bar and q1 bar. Okay, so now actually what will happen is at the second clock edge the q1 becomes 1 because it takes the just previous value of d1. Okay, and q2 will take just the previous value of d2, so that is 0, but q1 becomes 1. And as I mentioned that this is a combinational logic, so because q1 is 1 and q2 is 0, so we'll have q1 bar is equal to 0, right? And because q1 bar is 0, so d1 will be 0. Okay, is this point clear?
Please repeat.
Yeah, so what happens is the logic that arrives at the d1 is actually a combinational logic. So the moment q1 or q2 changes, okay, so that change is directly reflected at d1. Okay, and observe this that q1 changes its state based on d1's previous state because it's a flip-flop. And same thing with q2. So q2 will take the previous value of d2. Is that clear?
Yeah, clear.
Yeah, okay. So here we observe that q1 becomes 1 and q2 is 0. Because q1 is 1, so q1 bar will be 0, and because q1 bar is 0, so d1 will be 0. So that's why I shifted d1 from 1 to 0. Okay, so similarly,
Yes.
d2 and q1 are actually connected. You see, that's a wire. So whatever is the value of q1, so d2 will be same. Okay, so now let's figure out what is going to be q1. So q1 will take the previous state of d1, right? So it will be 0. Okay, similarly q2 will take the previous value of d2, so this will be like this, and d2 follows q1, so it is going to be this. Okay, so now let us figure out what is going to be d1. So d1 is going to be q2 bar dot q1 bar, but here q1 bar is 1 and q2 bar is 0, so again d1 will stay at 0 for the next clock edge. Okay, and now let us update q1. So q1 will take the previous value of d1, so that is 0, so it will stay at 0. q2 will take the previous value of d2, that is 0, so this will move to 0, and d2 follows q1, So it is same. Okay, now from these two we can observe that q1 is 0, so q1 bar is going to be 1, and q2 is also 0, so q2 bar is going to be 1. So q2 bar and q1 bar both are 1, and because of this reason d1 is 1. Okay, is this step clear?
Yes.
Okay, so if we want, okay, let us evaluate just one more state. Okay, so now what will happen, q1 is going to take the previous value of d1, so previous value of d1 is 1, so I'll make it a 1. Okay, and d2 is going to follow q1, right, and q2 will take the previous value of d2, that is 0, so let it stay at 0. Fine. So now what is going to be the value of d1? Can anyone tell me?
0.
Yeah. Okay, so d1's value is 0, and because d1's value is 0, q1 will be, the next state of q1 will be 0. Okay, and so q1 and d2 are connected, so this will also be 0, and it will take the previous value, q2 will take the previous value of d2. Okay, so you can continue it so on and so forth to observe that this thing is periodic. Okay, now let us figure out what is the frequency of q1. So to do that, okay, let me mark this point like this. Okay, and let me look at the point when it is repeating its value again. Okay, so this is the point when it is becoming 1 again and it is kind of repeating its value. Okay, so now after what period is it repeating its value? From here to here this is t, from here to here this is one more t, from here to here this is another t. So total q1 repeats itself after 3t. Okay, so if it is repeating itself after 3t, then we can write it like this, that this is 3 by f clock, right? So what is the frequency of q1? Can anyone answer?
12.
No.
3 by 12. 3 by 12, so 1 by 4.
Yeah, 1 by 4 is the period, but
Okay. Then 4. 4.
correct. So 4 kilohertz. Okay, so because 3 by f clock is the period, so the frequency of q1 will be f clock sorry, f clock by 3, and f clock is given as 12 kilohertz. So 12 kilohertz by 3, that is 4 kilohertz. Okay, does anyone have any doubt in this question? Or is it clear?
No. No. Clear. Clear.
Okay, okay, great. Okay, then we can move to the next question. Amit, do you have a doubt? Okay. Okay, so here we are given a structure, and we need to find the mod value of the counter. So what mod value means is, you need to mention after what value will it repeat itself. You remember, like we used to do for mod 4, mod 8 and those things. So similarly we have to figure out what is the maximum count that it can reach after which it repeats itself. Okay, so for this question what we need to do is let's make a table. Okay, so this is flip-flop 0, flip-flop 1, flip-flop 2, flip-flop 3. Okay, so if I'm mentioning J0, it means yeah, Amit, you have a question?
No, sir.
Okay.
No, sir.
Yeah, So if I am mentioning J0, it means the J input of the 0th flip-flop. If I am mentioning J1, it means the J input of the first flip-flop, and so on and so forth. Okay. So let me make a table: J0 K0, J1 K1, J2 K2, J3 K3. Okay, and let me call the outputs as A3, A2, A1, A0. Okay, so initially what happens is, okay, I think, are we missing something? No. Okay, so here you have to assume one thing. So the count will begin when count enable is 1. Okay, so for this complete evaluation we will assume that count enable is equal to 1. So when count enable is equal to 1, J0 and K0 is 1. Okay, but yeah, the initial state we are going to assume is A3, A2, A1, A0, everything is at 0, 0, 0, 0. Okay, so if everything is 0, so A0 is 0, because A0 is 0, J is 0, and K is 0 for the first case. Okay, so J1 K1 is 0, and similarly because this value is 0, so rest all the values of, yeah, rest all the J2 K2 and J3 K3 values will also be 0. Okay, okay, so now answer this. So if J0 K0 equals to 1 1, then what will happen to this state? Any answer?
Means the output.
Yes, what will happen to A3, A2, A1, A0?
1 0 0 0.
Yeah, okay, actually I have written it in reverse format, so yeah, it is 0 0 0.
Yeah, 0 0 0 1.
Yeah, correct. So basically J equals to 0, J equals to 1, K equals to 1 is the toggle condition. So whatever is the A0 bit, that will be toggled because of the J0 K0. Okay, so now once we have A3, A2, A1, A0 in this format, so this value is 1 and count enable is always 1. Okay, so now we observe that J0 K0 is going to be always 1 because count enable is always 1. Okay, so even if I write J0 K0 equals to 1 1 for everything, it is going to be same. Okay, now what happens to J1 K1? Because A0 is 1 and count enable is already 1, so J1 K1 becomes 1 1 in this case. Okay, but A1's value is 0, so the rest of the J and K input are going to be 0. Okay, so here what will happen is the 0th bit will toggle along with the first bit. Okay, so let me toggle the first bit. So the first bit will toggle from 0 to 1 and the 0th bit will toggle from 1 to 0. A2 will remain same and A3 will remain same because the JK input, they are at 0 0. Okay, so now who will tell me the value for J1 K1 for the next state? So just look at the pattern that we followed for the first clock and second clock. So what is going to be?
It will be 1 1 again.
Okay, J1 K1 will be 1 1.
Oh no. As A0 is 0, so it will be 0. Yeah. Sorry.
So
it will be 0.
Yeah, this
0
will
0.
be 0. What will happen to J2 K2?
Now it will be in 1 1 condition because A1 is 1 and no, the enable is 0. Our previous gate output is 0, so it
Correct.
will be in 0 0 now.
Yeah, correct. Yeah. And because J2 K2 is 0 0, and so J3 K3 will also be 0 0. Okay, it means that only the J0 K0 or the 0th flip flop will toggle, rest all are 0, so rest all will stay same. So let me keep all the bits same and toggle the last value. Okay. So now what about the next state? What will happen to J1 K1 in the next clock?
It will be 1 1 now.
Yeah.
A0 also.
And what about J2 K2?
It is. It will also be 1
Correct.
1.
And J3 K3?
Will remain same 0 0.
Okay. Yeah. So here what will happen is, let us keep J3 K3 as same, and we are going to toggle rest all the bits. So 0, if it toggles, it will be 1, rest will be 0 0. Okay. Similarly, if we go on doing that, so we will arrive at a point when we reach 1 1, then this will go on like it will reach 1 1 1 1. Okay, then again it will start from 0 0 0 0. So I'll suggest you to perform this exercise by yourself and validate this point, that the terminal state is going to be 1 1 1 1, and after the terminal state it is going to be 0 0 0 0. Okay, so this is going to be a good exercise if you practice. Okay, so what we are going to observe is, it is going from 0 to 15 and then it is restarting from 0. So it means it is a mod 16 counter. Okay, yeah. Then another thing I want you to notice here is, so there is something interesting that is happening here. Okay, so can anyone observe anything? Okay, let me also write down the initial state. Okay, initial state was like this. So can anyone observe these patterns and based on these patterns comment something, that what is happening with respect to the clock? Any answer or any guesses? XS3, no, something simpler. A0 all, okay, that's a great observation. Yeah, so that's what I wanted you to observe. A0 always toggles. Okay, so it means each time there is a clock pulse, A0 is going to switch from 1 to 0, 0 to 1, and so on and so forth. So is there any other observation about A1? Anyone? Any guesses? Please feel free to guess. Toggle for 2 clock pulses. Exactly. So if you observe the pattern that it is going to follow, so A0 is going to toggle for every clock pulse. Okay. A1 is going to toggle for every 2 clock pulses. Okay. So basically, if you take each of the outputs from either A0, A1, A2 or A3, so it is going to behave like a frequency division. So if you take the A0 bits, it is going to behave as frequency division by 2. If you take the A1 bit, it is going to behave like frequency division by 4. Similarly, this will be by 8 and this will be by 16. Okay, so this is a real life application of a counter, right? Because whatever we solve, so we must try to realize where is it going to fit in the big picture, right? So this is just one of the applications of a counter. Okay, you can implement a frequency divider using a counter by taking these respective outputs. Okay, I hope this point is clear. Is there any question in this particular problem? um, okay, great. Okay, so I request everyone to mute themselves. If they have any doubt, then they can unmute. Okay. Okay, so I'm assuming there is no doubt in this question, and we will move forward. Okay, so the next thing that is given to us is, so we are given a circuit. Okay, so that is mentioned in the right side. We have to identify the sequence which this particular circuit follows. Okay, so again, as I mentioned, that for these type of questions where you have a circuit and you are given an input, try to figure out what is the input to the flip-flop. Okay, so what is going to be your D0? Can someone tell me the equation for D0?
NOR of Q0 and Q1.
Correct. NOR of Q0 and Q1, or let me write it mathematically like this. Okay, so similarly, what is going to be D1?
That's Q0.
Correct, it's Q0. So let us assume that the initial state, yeah, so this is important, what assumption you are taking. So in most of the cases, we assume that the initial state is 0 0, unless it is specifically mentioned that this is the initial state from which you need to start the count. Okay, so I'm assuming that initially these two are 0 0, Q1 and Q0. Okay, 0 0. So if it is 0 0 in the first clock, what is it going to be in the next clock? So for that, let us figure out what is D0 going to be. So D0 is going to be NOR of these two. Okay, so NOR of these two will give 0 plus 0 complement. Okay, that is going to be 1. What will be D1? It will be nothing but the copy of Q0. So Q0 is 0 in the previous state, it is going to be 0. Okay, what is going to happen in the next clock? Can anyone tell me the combined value of Q1 and Q0 for this option? The third clock, 1 1. Okay, does everyone agree to this answer, 1 1?
It is supposed to be 0 1.
Q1 Q0.
1 0 then.
Correct, yeah. So why will it be 1 0? Because D0 is going to be NOR of Q0 plus Q0 and Q1, which is 0, right? Because one of the value is 1, so 1 bar is going to be 0. Okay, and Q1 is going to be Q0, so this value will propagate here. Okay, so and in the next state it is going to be 0 0. Okay, so we just need to figure out what is the sequence. So the sequence is 0 0 0 1 1 0 0 0. Okay, so that is option B. Okay, I hope this particular question is clear. Does anyone have any doubt in this question? Okay, so while solving these type of problems, the first point that you need to keep in mind is figure out the input equations. And once you figure out the input equations, it is going to be just simply creating that table or just a sequence, right? So always remember this is the first point. Okay, I hope this question is clear. If anyone has any doubt, please let me know. Okay, let's proceed to the next question. Okay, so the next question says, okay, we are given a circuit. So okay, this is X. Let me write it a bit. Yeah. Okay, so we are given a circuit, and we need to figure out difference even for the given input. Yeah, what is going to be the AB output? Okay, so can anyone tell me what should be the first step in this question? Because we solved 4 questions which were similar to this, so I assume that by observing this circuit, something must be coming to your mind, right? What should be the first step here?
First of all, sir, find out the values of J and K,
Correct.
which are here.
Okay, so
which will be connected on the flip-flops. Yes.
correct. So let me call this flip-flop as flip-flop A, this flip-flop as flip-flop B, and let me use notations like JA and KA to denote that it is belonging to the A flip-flop, and JB and KB, which implies that it is belonging to the B flip-flop. What is going to be the equation for JA? Can anyone tell me the equation for JA and KA? Okay, let's see what is the input to JA.
J is B. J
Yep.
is equals to B. J B.
Yeah. And what is KA?
K is equal to X naught J.
X complement into B. Yeah.
X complement into B.
After into
B.
Yeah,
B.
correct. So what is JB and KB?
J is X complement, sir. J be X complement.
Correct.
And K will be
So what is this gate?
XOR.
Correct.
XOR.
Yeah. So it should be
X XOR A.
A. Yeah, that's correct.
Yes.
Okay. So now let me mark the clock pulses like this. Okay. So this is a positive edge triggered. Okay. Okay, and it is given to us that the initial state of the circuit is reset to 0, 0. Okay, so for the first clock edge, what should be my JA and KA? Okay, given that A is equal to 0 and B is equal to 0 initially.
0, 0.
Okay, that is correct. So similarly, what will be JB and KB? Okay, for finding JB and KB, you need to know what is X. Okay, and what is X is given here. Okay, so when the clock edge arrives, what is the value of X?
0 it is.
Correct. So what is going to be JB?
JB is 1
Yeah.
and KB is X. That is 0. Same value as it.
No.
X and A both are A 0 na.
Yeah, okay, sorry, correct. Yeah, KB is, yeah, X is also 0 here, yeah. So what is going to be our A output? So initially AB was 0, 0, and now what is going to be A plus B plus? So for finding out A plus, look at this flip-flop. Finding out B plus, look at this flip-flop. Okay, so A0 is going to remain same because J and K equals to 0, 0 for this case. Okay, but what is going to happen with JB and KB? So because JK is equal to 1, 0 in this case, so B is going to be 1 irrespective of the previous state, right? So it is going to be 0, 1. Okay, so now for clock, the second clock. Okay, I'm just denoting the clock pulses here. So what is going to be JA and KA for this case, and JB and KB for this case?
One.
Sorry.
J1.
Yeah. J is 1.
And
K is
Ka equals to 0.
Correct. And what is JB and KB?
JB equals to also 1.
Mm,
JB 1.
no. Try again.
JB equals to x complement. Yes, sir. This goes to 0.
Yeah, correct.
J-
Okay, so while checking the x value, you should see what value is being sampled at that particular clock edge. Okay, so similarly, what will be KB?
KB equals to 1 XOR A.
And what is the value of A?
It was 0.
Correct. So ones or
So
zero
1,
is
1, 1.
correct.
1, 1.
Okay.
Okay,
So for this particular case, our AB initial was 0, 1, and it translates to A plus B plus. Okay. And what will be this A plus B plus?
A 0.
0, 1.
Okay.
Then
No.
1 0.
Yeah, 1 0.
1 0. 1 0. 1 0.
Okay, because JAK is equal to 1 0, so it means A plus will be 1 irrespective of any input. Okay, and JBKB is equal to 0 1, so B plus will be 0 irrespective of any input. Okay, so we figured out one sequence, so it is going to be 0 0. Okay, because it was the initial state. Okay, next it became 0 1, and next it became 1 0, and similarly you can continue it for the complete clock pulses. So let's say total there are 6 7. Okay, so I did for 1 2. Okay, for 3 also you have to repeat, assuming that A and B values are 1 0. Okay, similarly for 4 you have to assume whatever is the next state value for 3, that is the present state value for clock pulse 4, so on and so forth. If you go on doing this, okay, you will figure out what is going to be the waveform. Okay, is this point clear, or is there any doubt in this question? Okay, so the thing is, it may look like it's a lot of laborious work in these type of questions, but it is actually going to be a very good exercise if you try to solve it for all the 7 clock pulses. Okay, so you may observe a pattern that okay, maybe these things are repeating and it will be same again after some time, but if you try to solve for all the 7 clock pulses, it will give you a practice that how you should be solving, and usually with practice you will be better at solving these circuits. Okay, so if there is no doubt in this question, then we can move to the next question, question number 6. Okay, so in this question we are given two flip-flops, and again the method is going to be kind of similar, and we have to figure out what is the sequence that is produced at the output Y. Okay, so let us start with the first step. Let me call it TA, let me call this TB. Okay, so what is the equation for TA?
X dot BB.
Yeah, X dot B. For TB,
T6.
correct. Okay, so now let me make a table. TA is equal to x dot b, TB is equal to x, A, B and y. Okay, yeah, here we will have another equation for y. So y is nothing but AND of A and B. Okay. Okay, so now what is given to us? Initially all the flip-flop outputs are set to logic 1. Okay, so these informations are quite essential. Okay, otherwise here you can't assume that I can take A and B as 0 0, because here it is already given to you that the flip-flop outputs are already set to 1 1. Okay, so here it is given A is equal to B is equal to 1. So what is going to be your TA value? And it is also given x is equal to 1 forever. Okay,
1.
yeah, so TA is equal to 1 for the first clock. What is going to be TB?
1.
Correct. So what is A and B?
0 0.
Correct. And what will be Y subsequently? It will be 0.
0.
Okay, what will happen in the next clock?
0 1.
Okay, 0 1. What will be the value of A and B?
0 1.
0
Correct.
and 1.
Yeah, and Y will still be
0.
yeah. For the next clock?
1 1. Again.
Okay, 1 1.
It is 1 0
Correct.
0.
Correct. Okay, so the next one.
Again 0 1.
0 1. Okay.
1 1.
Okay, and this is going to be
1.
correct. Okay, so initially it was given to us that A equals to B equals to 1. So Y initial is equal to 1. Okay, so after Y initial, whatever terms we get, we have to just put it in a sequence. Okay, so it means the output of Y was 0. Okay, then 0, then 0, and then 1, and then
B
so
is
on.
the answer.
Yeah, B is the answer. Okay, is this question clear, or does anyone have any doubt in this question? Let me know if you have any doubt. Okay, else we can proceed to the next question, that is question 7. Okay, so here we are given a state table, okay, of a sequential circuit. So sequential circuit, it can be described in any way. So state table is one of the method to describe the behavior of a sequential circuit, that what is going to be the next state if a particular input is applied, and what is going to be the output for that particular transition. Okay, so it is mentioned to you, what is asked from you is what will be the output sequence for the given input sequence. Okay, so the input sequence is 1 1 1 0 0. Okay, so using this table you have to figure out what will be the output sequence, okay, given a particular set of input. So the input is basically x, okay, and the initial state is given to you as 0. Okay, so whenever you are presented with a question or a problem, figure out what informations are already available to you. Okay, so these are the essential information that you need to keep in mind to solve this problem. Okay, so if present state of AB is 0 0 and an input x is applied to be 1, what is going to be the output? How to figure it out from this table? Okay, so first thing, figure out what present state 0 0. Okay, present state 0 0 means I have two options. Okay, now the next thing, figure out what will happen if the input is 1. So input is 1 means this. Okay, Then we have zeroed down to only one row. So this is our corresponding output, 0. Okay. So my output sequence, the first number is going to be 0. Okay. Similarly, try for the next one. What is going to be the next state? Means what is going to be the present state now?
Zero one.
Correct.
Is
How did you figure it out? From here, right?
the next state? Yeah.
Correct.
Yes.
Okay. So now what is the input?
Now X is 0.
No.
1.
Yeah,
One.
X is 1. X is given here actually.
Oh, sorry. X is 1 now.
So if X is 1, then which one should I choose?
Fourth one combination.
Yeah, correct. The fourth combination. Okay. So here again the output is 0.
0.
Okay. Now what is going to be my present state?
1 0.
Correct. And what is the X value?
1.
Correct. And what is the corresponding table or output?
Next to the next.
Okay, next to next. Correct. So the output is again
0.
okay. And what is my next state?
1 1.
1 1. What is the input?
0.
Correct. So which one should I choose?
Next state. The next one.
Okay.
The output is 1.
Correct. Okay. So okay, let's do for the last one as well. So for the last one, what is the present
0
state?
0.
Okay.
0 0. Next, and the output is 0.
Okay, input is 0.
Input is 0. Sorry.
Okay.
And the output is 1.
Output is
0.
yeah,
Sorry.
0.
0 0. First.
Okay. So this is our required sequence. Okay, that is option C. Right. So it's like a map is given to you. You have to just figure out what is the way to to reach your destination, right? So the map is the state table that is mentioned here. Okay. Is everyone clear with this particular question and the method we did to figure out what is going to be the output? Does anyone have any doubt? Okay, great. So let's move on to the next question. Okay. So now again, Amit, I think, can you mute your mic for once?
Okay.
Yeah, sure. Yeah. So now this is another circuit that is given to us. Again, we have to repeat the same thing. So more we repeat, better is the practice, right? So okay. So you guys try to solve this one. So tell me, what am I going to do next? What should be the first step here?
Equation for
First of all,
TA
find
and
out
TB.
the inputs of the T.
Correct. So what is going to be my first?
A plus B.
Okay. And what is
And
TB?
A bar plus B.
A bar plus B. Okay. Next, what should I do?
Reset flip flops are reset to 0. So
Correct.
A and B are 0 0. That's the
Correct.
first clock. So 0th clock it is 0 0.
Correct. This is for 0th clock.
Yeah.
Okay. So that's
So
a really good thing. Means the first thing that we did is we wrote the equation. The next thing we saw what is the information that is already present with us. Okay. So what should be the next step?
Find out DA and TB.
Yeah.
And then A and B.
Correct. Okay. So for that, I will construct a table.
Yeah.
Okay. So let's say this is the first clock. Okay. Initial state is given to us as 0 0. What is TA and TB?
0 and 1.
Correct. So what will be A plus and B plus?
0, 1.
1 0.
0 1.
1 and 0.
No, it should be 0 and 1, right? Because TB only toggle because it is 1. So B will switch from 0 to 1. Is that clear?
Yeah.
Okay. So what happens in the next clock? Let me denote this clock as clock 1. This is clock 2. What happens in the second clock?
A and B are 0, 1.
Correct.
Then TA is 1.
Okay.
And TB is also 1.
TB is 1.
Correct. So what is A
So
plus
1
B
0.
plus?
1 0.
1 0. Correct. So what happens in the final clock?
Again, A and B are 1 0.
Correct.
Then
T
1
is 1.
Okay.
TB is
0.
1.
TB is?
Sorry, 0
Zero.
0 0
Okay.
0.
Okay. So what is
And
the?
it is 0 0 0.
Correct. Okay. So this is our required answer because it is asked that after 3 clock transitions, what is the output? So after the 3 clock transitions, 0 0 is the answer. So option A is correct. Is everyone clear with this particular question? Or does anyone have any doubt? Okay, so we can move forward then. Okay, so then we are given a circuit and we need to figure out what does the following circuit do. Okay, so there are many methods. If you are used to seeing this figure, then you can directly answer what it is, or else you can figure out what this circuit does by assuming an initial state. Yeah, I got one answer. So initial state, let's say it is 0 0 0 0. Okay, and then you proceed, like what will be the values, like 0 0 0 0. Okay, A B C E. Okay, so what will be the next value then?
One 0 0 0.
Correct. Next.
One 1 0.
Yeah, 1 1 0 0.
Yes.
Then similarly, if you follow it like this, it will be 1 1 0.
Yeah.
Then it will be again 1 1 1 1. Then it will be 0 1 1 1, and so on and so forth. So if any counter follows this particular pattern, that is called as a Johnson ring counter. Okay, so the benefit of this particular counter is you can observe that at any particular count there is no more than 1 bit toggling, right? So if we go from this state to this state, only 1 bit changes. This state to this state, 1 bit changes. This state to this state, 1 bit changes. Okay, so if you discuss something related to power consumption per bit or something, so in this case it is going to be less. Okay, so that's a benefit of Johnson ring counter, and this is actually a Johnson ring counter. So either you can visually tell that it is behaving like this, otherwise find what is the behavior and then determine your answer. I hope everyone is clear with this point. So moving on to the next question. Okay, so in the next question we are given a circuit again. Okay, and let's figure out what are the information that is given to us. Okay, it is mentioned that D in and reset is always tied to logic 1. Okay, sorry, logic 1 and logic 0 respectively. So reset is always 0, and this is a active high reset. It means if it is 0, the reset is not active. Okay, and D in is always 1. Which of the following sequence is produced by P odd? So we have to figure out what is the output at P odd. Okay, so what should be my first step? So the first step is going to be same, figure out the equation. What is the equation?
D in XOR period.
Correct. D in XOR period. Okay. What is, can I simplify this further? Okay, so if anyone remembers, I mentioned one trick during the initial logic gates classes. I think fifth or fourth tutorial, that if you have a XOR and you have a 1 to it, so it will basically toggle whatever you are presenting here, right? So here we see that D in is given to us as 1, so this is 1 XOR period. So we can reduce it further by writing it complement of period. Is this point clear for everyone?
Yes.
Okay. So this actually simplifies our discussion a bit further, right? So it means if I assume that initially period was 0, okay, then after the first clock it becomes
1.
correct. Then after the second clock it becomes
0.
correct.
Again 1.
Correct.
Again 0.
Yeah. So it actually toggles each time there is a clock edge, right? So out of these options, which is the one that suits us? That is option
B.
Correct.
B.
Right. So as you can see that this actually behaves as a T flip-flop, right? T flip-flop with the value 1, right? So this black box can be treated as a T flip-flop as well. Okay. So these are some of the observations. So if you are able to observe it from the very beginning, then you can mention it that okay, I need not compute this equation because I see a T flip-flop with an input 1. So what will happen is it will toggle each time. Okay. I hope everyone is clear with this solution. Okay, and please remember this point, that if you are doing a XOR operation and if one of the input is 1, then the output is going to be the complement of the second input. Okay, if it is 0, then the output is going to be same as the second input. Okay, so let us move to the next question. Okay, so in the next question we have to figure out what is the mod value of this particular asynchronous counter. Okay, so when you are given a reset followed by a logic, okay, first thing you have to do is figure out what is the equation of the reset. Okay, so can anyone tell me what is the equation of this reset?
QA
into
QD into clock. Clock is
into clock. Okay, let me assume that this will
complement of
only be,
that.
yeah, correct. So let me assume that clock is always going to be high. Okay, so this is just
Then
to
it is
mention,
1.
yeah,
QA into QD.
okay. So the reset equation is QA into QD whole complement. Okay, and when do these the flip-flops they get reset? So if this particular notation,
Both are 0, 0.
correct. So if reset is 0, okay, at that moment all the flip-flops they get reset because it is an active low reset. You see it is written that CLR bar. So CLR bar means whenever this reset signal is 0, it is going to reset all the flip-flops. Okay, now let me do another thing. So we have another information given here, MSB and LSB. Okay, so whenever you are given a number, let's say 1, 8, 3, 4. So this is just, let me put it something generic, X, Y, Z. Okay, so this is the MSB and this is the LSB. So MSB stands for most significant bit and LSB is least significant bit. So here we are already given what is the MSB and what is the LSB. Okay, so if I have to arrange, then it will be QD, QC, QB, QA in this fashion. Okay, now 8. Okay, no. Okay, so try to answer this question. When is reset going to be 0?
QD, QA equal to 1. Both are equal to 1, then
Correct. Okay, so now answer this question. So can you see this entire structure as an up counter? So forget the reset for the time being. So this entire structure, is anyone able to see that it's an up counter? Okay, and why is it an up counter? Because JK input in all the cases it is tied to VDD. Okay, in this case it is written VCC. So basically it refers to that it is tied to high or 1. So it means it will behave like a T flip-flop with T is equal to 1, right? It will keep on toggling the states, right? Then the next thing is observe at what instant it toggles. So this guy is going to toggle each time there is a change in clock from high to low. And this time, and the second one, it toggles whenever the Q output of the first flip-flop, it changes from high to low, right? Just like we made an observation in the beginning, right? In one of the questions, okay, in this particular question, you remember? So here you can observe that it is toggling at each clock edge and it is toggling at each after 2 clock edges, right? So the same thing is actually going to happen here. Okay, okay, sorry, this is question, yeah, here. Then the same thing follows here, same thing follows here. Okay, so this is basically an up counter. Okay, so up counter, let me assume that the initial state is 0 0 0 0. Okay, so let's say I fix these two values. So what is the minimum value for which QD QA is equal to 1, and I am starting the count from 0 0 0 0. So tell me the minimum value for which QD QA equals to 1 1. Can anyone tell me?
9.
Correct. Okay, so it means the moment the output of these combinations, so it reaches 9, my reset becomes 0 and everything goes back to 0, right? It means it will do the up count from 0 0 0 0 till 1 0 0 1. After that it again goes to 0 0 0 0 state, right? Correct. So the mod of this counter is 10, right? Is everyone clear with this point, or is there anyone who needs an additional explanation?
Yes, sir. I need additional explanation.
Okay, so did you understand this point, how we derived the reset logic?
Yes, sir.
Okay, so after deriving the reset logic, were you able to visualize that this was an up counter, this entire structure?
Sir, no, I can't get, sir.
Okay, so what happens is you can see that these are actually a bunch of flip-flops. There are 4 flip-flops. Okay, and the inputs of these flip-flop JK flip-flops, it is tied to 1. Okay, so if the inputs of JK flip-flop is tied to 1, it means that whatever is the present state, it is going to toggle in the next state, right?
Yes, sir.
So it means, let me assume, as it is given that it is LSB, so if QA, okay, let me draw the clock like this. Okay, so QA is going to toggle at each, sorry, this is negative edge, so at each negative edge, if it starts from 0, so it will toggle here, it will toggle here, it will toggle here, and so on and so forth, right? It means it will toggle at each of the clock edge,
Okay, sir.
right? And what happens is this Q output, let me call it QA, okay, it is given as QA. This QA is acting as a clock to the next flip-flop.
Yes, sir.
Okay, so what happens is the next flip-flop will also follow this trend, that whenever it sees that there is a drop, then it will toggle.
Okay, sir.
Okay, so here again it will follow the same thing, that it is dropping. Okay, so QB, so you can observe that QA is toggling at every clock edge, QB is toggling at every 2 clock edges,
Yes, sir.
right? And this is similar to the question that we did earlier, right? Oh, sorry, this one,
Okay, sir.
right? So this means that this is an up counter. So are you convinced that this is an up counter now?
Yes, sir. Yes, sir.
Okay, so the next thing that I did is I assumed that the initial state is 0 0 0 0, and it is up counting, so it will mean that the next state is going to be 0 0 0 1, and so on and so forth. But then I went back to the reset logic again, because once the reset is high, then my flip-flop is going to be 0 0 0 0.
Okay, sir.
Correct. So we now figured out that reset is the minimum value for which the reset is going to be high is 9.
Yes, sir.
Right? Because, yeah, so the important point is the minimum value, because this reset is also going to be high for 1 0 1 1. Correct?
Yes, sir. Yes, sir.
But we will never arrive at this particular value. Why? Because it becomes 0 at this value itself. So that's why the point minimum value is important.
Okay, sir.
Okay, so we figured out that minimum value is 9. So our count will go from 0 to 9, and it will again start from 0.
Okay, sir. Clear.
So that's a mod 10 counter. Is that point clear?
Clear. Clear, sir.
Okay.
Yeah.
Okay, so is there any other doubt in this question? Okay, if not, then let's proceed to the next question. Okay, so here we are given initial state in this manner. We have to figure out what is the sequence produced by the following circuit. Okay, so let's start with the equations. What is dA?
QA XR QC.
Correct. dB?
DB is QA.
Correct. DC?
Again QB.
Okay, the next thing we'll do is we draw the table, we make the table. We have dA, dB, DC, QA plus, QB plus, QC plus. Okay, so it is mentioned that the initial state is 1 0 1. Okay, and here the order also matters, so you just note down what is the order that is given. if it would have been given QC, QB, QA, then you were supposed to answer in that order, but it is given that it is QA, QB, QC. So we will put these numbers in that format as well. Okay, so what is going to be the value of DA, DB and DC?
DA is 0.
Okay. DB?
DB 1.
Okay.
DC 0.
Correct. So what will be the next state?
Next state is
0, 1, 0.
0, 1, 0.
Correct. So whatever is going to be the DA value, that will reflect at the next state. Okay. So my present state
0,
here
1,
will be
0.
correct.
0, 1, 0.
No. What is going to be DA, DB, DC?
DA is 1.
Mm-hmm.
0. 0.
Okay.
DB is 0.
1.
Okay.
And 1.
Correct. So it will be 0, 0, 1. Okay. So what will be DA, DB, DC?
1,
Correct.
0,
Correct.
0.
Correct.
1, 0, 0.
Okay. So the sequence that we are looking for is, initially it was given to us that it is
1, 0, 1.
Correct.
0, 1, 0. 0, 0, 1.
correct. Okay, so option A is the correct option. Is everyone clear with this particular point, or is there any further explanation that is needed? Okay, so moving on to the next question. Okay, great. So the next question we are given a, okay, so this is also similar to the previous questions that we have done, and in this case we have to tell what is the sequence at the output that is going to be generated. Okay, so again, always remember the first step, that is writing down the equation. So what is the equation for D3?
Q1 XOR
Q0 XOR Q1.
Correct. For rest, D2?
Q1.
Okay. No.
Sorry, it's Q3.
Okay. What is D1?
Q2.
Correct. And D0?
Q1.
No. Okay. Yeah, correct. So then you can see that the output that we are supposed to find is basically nothing but Q0. Does everyone agree?
Yeah.
Okay. So using these, what we will do is we will again make the transition table. So Q3, Q2, Q1, Q0. So yeah, it's definitely hard work to construct the entire table and figure out the answer, but it's worth it, right? Okay, and what is needed is this Q0, the sequence. Okay, so let us start. It is mentioned that the initial state is 0, 0, 0, 1. Okay, so tell me D3, D1, sorry, D3, D2, D1, D0.
D3 0.
Think once again.
Oh, sorry.
D3 1.
1, 1.
Correct. So you need to look at these two bits for determining the D3 value. Okay. So what is D2, D1, D0?
0. 0. 0.
Correct. So what is the next state? It is going to be the same as D, right?
Same. Yeah.
Correct. So what will be the
Now
D3?
it is present state.
Yeah.
Now it is 0. 1. 0, 0.
Correct.
0,
Okay.
0,
Okay.
1, 0.
Okay.
1, 0, 0, 1.
Correct. Okay, so let us observe the output at this point itself. Okay, so initially it was given to us that this was the initial state, so I will take that as well. Okay, here q0 is 1, and after that we have 0 0 0 1. Okay, so option D is correct. Okay,
Yeah.
is there any doubt in this question? So it is kind of similar to the previous questions, and here we just need to figure out what is going to be the output sequence, right? Okay, so now the next question. Okay, so try to figure this out. So can anyone tell me what is going to be the equation for D?
It is JQ
J.
complement. JQ complement plus
plus
K naught Q.
okay, K naught Q. Does everyone agree, or is there anyone who is willing to give another response, a different response? Okay, so what is the information that is given to us? J equals to 0 and K equals to 1. Okay, so if J equals to 0, then this term becomes 0. If K equals to 1, then this term becomes 0. So D is equal to 0. Okay, so what will be the output of the following circuit? So once clock is high, the Q is going to be 0. Right. So the only thing here we needed to figure out is the equation for D. Okay. So that was the final question for the day. Now let us revisit what we covered in today's session. Okay. So today's session, it started with this particular circuit, and we figured out how many clock cycles were needed to arrive at a particular condition. So it is not necessary that this condition will arise every time. Okay, so let's say the initial state is given something different and you have to reach another state. Okay, so you need to figure it out by making this present state next state table. Okay, so try to be comfortable with constructing these tables as quickly as possible, just like the Carnot maps. Okay, because they are going to be handy when you actually are solving bigger questions, right? So after constructing this table, we just count the number of clock cycles. Okay, and we see that at the fourth clock cycle we arrive at the desired output, that is 0110. In the next question, what we did is, so in this question, so what I have seen is some people get confused with which input is going to get updated when. Okay, so here one thing that you need to remember is, if it is a combinational circuit, the moment the input to that combinational circuit changes, the output will also change at that moment itself. It will not wait for the clock to come. Okay, and if it is a sequential circuit, then based on the arrival of the clock pulse or based on the enable signal, it will change its state. Okay, so these 2 points are quite important, and please try to remember it. So what I did is, I figured out the equation for D1 and D2. Okay, and based on that, I started drawing the timing diagrams. Okay, and in these timing diagrams, what I did is, I drew the clock first. Okay, after drawing the clock, I derived what is going to be the D1, and I assumed that Q1 and Q2 are set to 0 for the initial period, right? So Q2 bar Q1 bar was 1, and based on that, D1 was 1. Okay, so Q1 stays there, D2 is same as Q1. Okay, and Q2 is just previous value of D2. Okay, similarly Q1 is previous value of D1. Okay, if you make this observation, then drawing the timing diagram becomes easier for you. And once I have drawn the timing diagram, what I look for is when is that particular input going to repeat itself. Okay, so when I say that a particular value is repeating itself after a certain time, then that thing becomes its time period, that particular time, right? That is the definition of time period. And 1 by that time period basically is your frequency, right? So similarly, we observe that Q1 repeats itself after 3t clock. Okay, so that is basically 3 by f clock, which means that the frequency gets divided by 3. Okay, and the original frequency of the clock was given to be 12 kilohertz. So the frequency of Q1 becomes 12 by 3, that is 4 kilohertz. Okay, option D. Sorry. Yeah. So the next question was related to figuring out the modulus value of this particular counter. And as mentioned earlier, mod value is the value at which the counter repeats itself. Okay, the maximum count that is possible, after which it starts the reset count. Okay, and what we did is one by one we figured out what is the input to each of the flip-flops. Okay, and so here before starting to figure out the equation, please remember to give proper notations. Okay, so J0, K0, J1, K1, otherwise it will lead to confusion at the later stages. Okay, so it's better to denote the notations properly from the very first instance itself. Okay, then we made another interesting observation here, that the lowermost bit in the flip-flop in the counter, it toggles at each of the clock edge, right? And as we move from the lower significant bit to the most significant bit, so the frequency starts getting divided by 2. Correct. So what it basically tells us is, so A1 will toggle after each clock edge, sorry, A0 will toggle after each clock edge, A1 will toggle after each 2 clock edges, A2 will toggle after each 4 clock edges, right? And this is a practical application for using it as a frequency divider. So counters are often used as a frequency divider. Okay. So the next thing that we did is, so we were given a circuit, and so this standard method we are going to follow everywhere, that you figure out the equations that is going to the input of the flip-flop. Yes, Suresh, you have a doubt?
Actually, it is not related to this class. Maybe I am having question related assignment of 5.
Actually,
Shall I?
assignment questions we are not allowed to discuss. So maybe you can put that question in the forum itself, so that some other, like there are some course TAs as well. Okay, so
Okay.
those doubts should be addressed by them, and we are not allowed to discuss the assignment related questions.
Mailed them 3 days back, but I didn't get any confirmation from that.
You can send them a gentle reminder then.
Okay. Thank you.
Yeah. Okay, so here we try to figure out the D0 and D1 value, and after figuring out, so what we do is we take an initial state assumption that it is 0 0. So if initial state is not present or not mentioned in the question, then you can safely assume it to be 0 0. Okay, and then proceed with figuring out what is the D0 D1 value and what is the Q1 Q0 value. Okay, that's what we did, and we arrived at the answer. Okay, so the next thing is related to same figuring out the AB, the sequence AB that is going to be produced, and here also we did the same thing. We first figured out the equation for JA, JB, KA, KB, and then you need to also take note that when is the input being sampled by the clock. Okay, so you should be able to figure out whether the clock is a positive edge triggered or a negative edge triggered, because had this been a negative edge triggered, then the X value that will go to the input is going to be 1. But because we figured out it's a positive edge triggered, So the x value that is sampled by the first clock edge was 0. Okay, so how will you know that whether it's a positive edge triggered or negative edge triggered? So if it is written clock, or if there is no bubble here, okay, so it means it's a positive edge triggered clock. Okay, had there been a bubble, or if it would have been written like clock bar, then it would have been a negative edge triggered clock. Okay, so please take note of these points, and while solving the equations, so these are the first things that you need to observe, and also observe what is the information that is already provided to you in the question. Like here it is given that assume the initial state to be 0 0. Okay, and then we proceed. Okay, in the next question we were given a circuit and we were supposed to figure out what is going to be the y output. We repeat the same thing, we figure out the input equations. Okay, then we proceed by making a table and figuring out what is going to be the y value, that is the output, and we see that y output is a dot b. Okay, and yeah, so here the interesting thing was the x value was given as 1, and it is mentioned that the flip-flop outputs are set to logic 1. So here you can't simply take the assumption that a and b equals to 0 0, because here you are already provided with the information what should you take the initial state. Okay, then the rest of the procedure is same. Okay, and we figure out why. Okay, so the next question was a bit different. So basically you are given with a state table of a sequential circuit, and you need to figure out for this particular input what should be my next state and what should be the output. So here everything is given to you. So the circuit's behavior is described, and so it behaves like a so as I mentioned, it behaves like a map, and you need to figure out what is going to be the output from this particular map. So you just need to be able to figure out, okay, for which input what is the output. Okay, so for the next circuit what we did is we have to figure out what is the output after 3 clock transitions. Okay, we are already given the reset state. Okay, and then we figure out the equations. Okay, then we construct the table, and from this table we construct what is the terminal output, that after 3 clock cycles. Okay, question 9, it focuses on a Johnson ring counter. This is basically figuring out if a circuit is given to you, what is the behavior of the circuit. It comes with either practice, or you can also do the hand calculation and figure out what is going to be the behavior of the circuit, and based on the behavior you can tell that okay, this is behaving like a Johnson ring counter, so this is a Johnson ring counter. Okay, then the next question was related to, again, so in digital circuits, okay, be it any electronics course, so be it digital circuits or analog circuits, so observation and intuition are something that comes with practice. So if you are able to observe that this particular circuit is a T flip-flop, and the input is 1, then you need not go through this entire equation reduction. You can directly say that it is going to toggle at each instance. Okay, otherwise what you can do is you can write the equations, okay, then solve them and reduce them to a form that is that will be easier for you to determine the output. Okay, and even for this particular reduction I used this particular property. Okay, and this property was discussed in our previous tutorial sessions, and using this property I figured out what is going to be the P-odd. Okay, because it toggles at every instance, so at each clock it is going to toggle from 0 1 0. In the next question we were supposed to figure out what is the mod value of this asynchronous counter. So whenever such a counter is given that it has a reset logic, so the first thing that you should do is figure out what is the equation for that reset logic. The next thing that you should figure out is when is that reset logic going to clear out the flip-flops. Okay, so here we observe that it is a negative edge triggered flip-flop, so it was going to clear out the flip-flop when the reset is going to be 0. So for reset equals to 0, we figured out what is the combination that is required, and we took the minimum combination that is needed, that after that particular state it will go back to 0, and that is going to be the modulus of the counter. Okay, then we figured out that this is basically an up counter based on our observation from question number 4, right? That this particular output, it toggles at each clock, this toggles at each 2 clock, this toggles at each 4 clock, so on and so forth. So that's basically the behavior of an up counter, right? So it is going to start the count from 0 0, and it is going to go till 1 0 0 1. Okay, so let us assume for some reason if it were not an up counter but a down counter. Okay, so for the down counter, maybe the initial state would have been different. Okay, so and based on that initial state, what you were supposed to do is you had to figure out what is the maximum value for QD and QA for that reset logic to be enabled. Okay, so you have to give a bit of thought in such type of questions, but the thinking process is going to remain same. Figure out when is the circuit going to be reset. Okay, so whether it is to take the maximum value or minimum value, it depends on whether it is an up counter or a down counter, right? Okay, so the next question was also related to figuring out the sequence. So here first thing is we figure out what is the equation, based on the equation figuring out what is the output. Okay, and then from that output you form the sequence, right? Okay, next question 13 was also similar, but here the output was connected to Q0, so we had to figure out what is the sequence that Q0 is going to follow, and that is what we reported in this question and tried to solve. So as I have repeatedly mentioned this, that the process that we use to solve these questions, they are actually quite important, and the more you solve these problems, the more better you get. Okay, so it's like it may seem to be easy, but these type of questions, it actually needs a good bit of practice. Okay, so if you practice it regularly, then it will be good. And the last question was related to figuring out the equation for the D flip-flop. Okay, and once you figure it out, so it becomes simpler, right? Because the initial state is given to you, J and K value. Okay, so these were the set of questions that I thought of covering today. And so the recorded lecture, this particular recorded session will be available on my YouTube channel, and these annotated slides, they will be shared by the NPTEL team. When you go through the annotated slides, so one request is do not look at the solution immediately, but to first approach the question, try to understand what the question is asking, try to solve on your own. If you arrive at the answer, that's great. If you don't arrive at the answer, then try to see where you have gone wrong. Okay, so this will help you in the future when taking any advanced course, or if you're planning for a career in digital electronics, because these circuits actually form the foundations for your advanced system design courses related to digital system design. Okay, so I hope this session was helpful for you. If you have any queries, please let me know. Okay, how to choose the max and min value in question 11. Okay. Okay, so in this question, what I did is I figured out that it is going to be an up counter. Okay, so once I figure out that it's an up counter, then so when is the first time QDQA is going to be 1 1? Nine, correct. Okay, what can be the next, what can be any other value when QD and QA will be 1 1? Yeah, it can be 11, it can be 15, it can be anything, right? But once I reach 9, will I be ever able to reach 11 or 15? No, right? Because once you reach 9, then the counter resets and you go back to 0000. Correct. So that's why I have to take the minimum value in this case. Got it? So similarly, you have to think a bit like whether the other states means, because in this case QB QC can have multiple combinations, right? You just know QD and QA because they were in the reset equation, but you don't know what is QC and QB. So in that case, you have to figure out what are the other possible combinations that can occur. So can occur is the term that you need to keep in mind, and based on your observation you need to see whether those terms are actually going to occur. If they are not going to occur, then you need not bother about them. Okay, so instead of saying minimum or maximum, I should say that which can occur before. Okay, so I hope that answers your question, Omkar. Okay, is there any other doubt that anyone has? So yeah, if you have a doubt related to whatever was covered in today's session, please feel free to use the NPTEL forum to raise your questions, and I will try to solve the queries if you have any. Okay, so if you have any questions related to today's session, just let me know. I'll be here for some time. Else, today's session is over. Thanks for joining. Okay, I'll be here for some time. If anyone has any query, then they can just let me know. Thank you.
Thanks. But one thing is, I think you have cough and cold today, na?
Yeah.
You are suffering from so take care and take medicines also, yeah?
Yeah, thank you.
Okay.
Actually, it's because of the weather here in Mumbai. So
Weather, yeah, everywhere it is going on, huh? So I have realized that. So it's very difficult to speak in this situation, nah? So okay, you may gargle or you take vapors. That will be helpful for
yeah,
you.
sure.
I think.
Thanks. Yeah.
Okay, yeah. Goodbye.
Yeah. Bye.